Hey guys, in this video we're going to look at a couple of examples for apportionment. So this is section 4.1 and you will need a calculator for this one. Alright, so if we look at this first example, we're given the Bandana Republic consists of 4 states. They're listed as A, B, C, and D. And we have their populations listed below. So what we have are 160 seats in Congress, and we want to apportion these seats based on the population. So the higher the population, the more seats you should get. All right, so the two most important things are the number of seats. We definitely need to know that. And notice here we have this total population of 8 million. So the first thing I'm asked to do is find the standard divisor. The formulas for this are on the previous page, but remember that standard divisor is the total population divided by the number of seats. So here's our total population of 8 million. And we're going to divide that by the 160 seats. All right, so I'm going to stick that in my calculator real quick. All right, and this comes out 50,000. So what the standard divisor tells us in this case is the number of people represented by each seat in Congress. So this is people per seat. All right, so we're going to use this number to find each state's quota. So this will tell us how many seats each state deserves based on their population. So for the quota of A, and again these formulas are on the previous page, we are going to do the population of A divided by the standard divisor. So the population of A is 3,310,000 and our standard divisor is 50,000. So on these, if you do have to round, we generally round to 2 decimal places. Sometimes it's not necessary. In this case, we got exactly 66.2. I don't know how well you guys can see that. It's probably better on this side of the camera. All right, so they get 66.2 seats. Now, we're not worried about how to round this or split it up right now. We're just trying to figure out how many seats they deserve. All right, so let's go ahead and do state B. So the quota of B will be the population of B divided by the standard divisor. So that will be 2,670,000 divided by 50,000. All right, so we'll put that in our calculator. And that comes out 53.4 seats. Okay, so next we'll do the quotient for C. So we want the population of C divided by the standard divisor. And that's going to be 1,330,000 divided by our standard divisor of 50,000. Okay, so we put that in. And this comes out to be 26.6 seats. All right, so we've got one left. We've got the quotient for D, so we'll do the population of D divided by the standard divisor. This is 690,000 divided by 50,000. And this is our smallest population, so it should have the least number of seats. Now, if I just want to check and see if I did this right, I know that I'm splitting up 160 seats. So if I just add all these together, 66.2 plus 53.4 plus 26.6 plus 13.8, that adds up to be 160. So that's a pretty good check that I did this right. Now remember, we can't give someone a partial seat, but we'll worry about how to split up those decimal parts in the next section. All right, so let's try one more example. So we have a little note here. Conventional rounding is not an apportionment method. So you're tempted to round your answers up or down and just sort of resist that urge because that's typically not how we do apportionment. All right, so second example, we've got a transit system for an area that operates 6 bus routes. So A, B, C, D, E, and F. And they have a total of 125 buses. So that's probably going to be important. The number of buses apportioned to each route is based on the number of passengers riding that route. So the table below shows the daily average ridership on each route. So that means for Route A, over a full day, they will have a total of about 45,300 people ride that bus route. All right, so this one doesn't give us a total. So we need to go ahead and put that down in the end. Okay, so we're going to add up all the ridership. So 45,300, 31,070, 20,420, 14,160, 10,260, and 8,720. All right, so I put all that in, and I do get a total of 130,000. This is clearly a much bigger town than San Angelo, right? All right, so first thing we're asked to do is find the standard divisor. So remember, standard divisor is total population divided by number of seats. So in this case, the seats are not as obvious as they were in the first example, but you think about what are the things we're trying to split up. We're trying to split up the buses. We're trying to figure out which buses are going to go to which routes. Okay, so we're going to send more buses to A than we do to F, for example. So 125 is going to be our number of seats. So we'll do 130,000 divided by 125. And we get 1,040 as our standard divisor. Now on the second question, it asks, explain what the standard divisor represents on this problem. So remember, this was people and this was buses. So we're going to say, on average, there are 1,040 people per bus. Now keep in mind that's not all at once, right? That's over the course of a day, so they'll run through their routes many times. All right, so now let's find each state's quota, or in this case, each bus route's quota. So if we do the quota for A, it will be the population of A divided by the standard divisor. So 45,300 divided by 1040. All right, so can't see the calculator quite as well over here. Let me move my light. All right, 45,300 divided by 1040. Now let's think about rounding this. I'm going to round this to 2 decimal places. So notice I have 5, 5, but then I have a 7. So when I'm rounding to 2 decimal places, I look at 3 places and say, okay, the 7 is going to round that up. So anything 5 or bigger will round this number up. So it's going to be 43.56. And it's really important that you round correctly. Sometimes it's going to mess up your total at the end. So remember, this is buses. So this is how many buses Route A should have, or what they deserve. All right, so let's do the same thing for B. Population of B divided by standard divisor. 31,070 divided by 1040. All right, so once again, we need to round. So we have 29.875. The 5 is going to bump that 7 up, and it's going to be 29.88. All right, so the quota for C, population of C divided by standard divisor. So 20,490 divided by 1040. and that comes out 19.701. So the 1's going to tell us not to round up, so that's going to stay a 0. So it's going to be 19.70. So that's the number of buses that Route C deserves. All right, so quota for D, population of D divided by standard divisor. So that's going to be 14,160 over 1040. I'm not going to show the calculator on these last three except for the rounding part. I think y'all are kind of getting the hang of it now. All right, so this one I get 13.615, so that 5 tells me to bump up the 1, and that's going to be 13.62. And then I've got 2 more, so the quota of E will be the population of E divided by the standard divisor. So 10,260 divided by 1040. And this one comes out 9.865. Again, we're going to round up, and that's going to be 9.87. And then finally, our last one for F, we're going to do a population of 8720. We're going to divide by 1040. And we get 8.384. So that 4 tells us not to round up, so that's going to stay 8.38. Now remember, if I add all of these together, I should get the total number of seats, which in this case was buses. So sometimes if you've been rounding, it may not add perfectly. So I'm going to add these up real quick. Just be patient with me while I put all this in the calculator. So when I add it together, I get 125.01. So notice it's almost 125. That 0.01 is just an error from the rounding you've been doing. So as long as it's really close, it is correct. It's just that you've got a little bit of rounding error on that problem.